Welcome to NemaTrident Up Close and Personal. My name's Burke. I'm the marketing lead for Turf and Landscape for Europe, Africa and the Middle East. And this is Sarah James. She's the team leader for the Biologicals Formulation Group here in Gillett's Hill. So really pleased you come to see us. What we're going to be talking about today is nematodes, the key species, the life cycle and survival factors. Then Sarah's going to take you up close and personal to see some nematodes really up close, and also the hosts as well, the larvae up close as well. So let's get into it. First nematode we're going to talk about is Steinernema feltii. So this one is targeted at leatherjackets, and there's over 100 species of Steinernema, but this one's particularly selected to be efficient against leatherjackets. So there's different types of strategy that nematodes use when they're hunting for the prey. There's cruisers, so these go hunting their prey deep into the soil and move a lot, and there's ambushers that stay near the surface and wait for the pest to come or host to come, and then they'll attack. Now Steinernema feltii is kind of an intermediate, it's like a hybrid, so it does move to a certain extent but not quite as far as the cruisers. But this movement behaviour is really important, and it means it can be used in both the spring and the autumn period, as long as the temperature is above 8 degrees. And that could be as far as May if you're in the spring period. But that temperature is really, really important, and we'll come back to talk about that as well. So the full rate of the NemaTrident F is 5 billion nematodes per hectare. That's the full application rate. But you do need this 8 degrees for 3 to 6 hours per day to make it effective. And this nematode is one of the bigger ones, about 0.8 millimetre in length. And so this one is targeted specifically at leatherjackets. The second one we're going to talk about is Heterorhabditis bacteriophora. Now this one is specifically targeted at chafer grubs, so the whole range of chafer grubs. Now this one is a cruiser, so this one does go deep into the soil to locate the grubs deep in the soil if that's where they are, and will control them effectively there. Again, the rate is 5 billion per hectare, that's the full rate, but for this one you need 12 degrees centigrade for 3 to 6 hours a day. So a higher temperature range, but during that summer period, that should be fine. And one other I wanted to talk about today is Steinernema carpocapsae. Now this one we won't be supplying into the UK, but I think it's worth talking about because it's an important species from the past, and you may actually see it on the market in the UK. So this one controls leatherjackets, but as you can see in the screen, it needs 14 degrees centigrade to be effective. Now the flight period for cranefly has shifted from August to early September to end of September to even early October now. So with that shift in behaviour and flight pattern, the temperatures are no longer effective or suitable for the carpocapsae. So we don't supply this into the UK, but you may see it in the market, and I think it's useful that you know about its characteristics. And this one is an out and out ambusher. So this would only be suitable for the autumn anyway and not for the spring period. Okay, so when you apply the full rate of 5 billion nematodes, how many per centimetre does that equate to? Well, the full rate of 5 billion is 50 nematodes per square centimetre, and that half rate is 25. And why is that relevant? Because when you use it with a celloprine, you can cut down to the half rate. So that may sound a lot, but you need more than one nematode to control a grub or a larvae. You might need between 4 to 10, depending on the size. The very big larvae, the third instar, you may need 10 nematodes to kill that because they've got their own defence mechanisms. So really important that you think about survival of these, how to keep the maximum number viable and in the soil and active. So we'll come back to that, but really important you try to maintain the viability as much as possible and keep everyone alive. So it's quite complicated with when we talk about these high numbers of nematodes that you need, 5 billion, but you can see here, very simply, if you break it down to packs, 10 packs or 5 packs, depending on you want full or half rate. So that's the way to think about it. Just numbers of packs is a much simpler way to think about the application rate. So we look at the life cycle now. So these are parasitic nematodes. That means they need a host to survive. The only part of the life cycle that doesn't need a host is the infective juvenile, and this is the one that we supply in the products that we send out in NemaTrident. So the infective juvenile will go out looking for the host. When it locates it, with its strategy of either being an ambusher or a cruiser, it will penetrate the host. And so look for soft tissue in the grub, but from the back of the neck, the anus or the mouth, penetrate through there, and then it will multiply up and it will release the bacterium into the host. It's actually this bacterium that kills the grub and not the nematode itself. That bacterium is released into the grub, it releases toxins, and this causes septicemia, and the grub will die very rapidly, normally within 2 days. And then what will happen is that you get a reproduction of the nematodes within the grub, and then perhaps within 7 days, 14 days, nematodes will be released from that grub into the environment again, and they can go out hunting more hosts. So how do we keep as many as possible alive? Well, we need to bear in mind certain factors. They're very sensitive to UV light, so applying the nematodes in the morning or in the evening, or when it's cloudy, is the best strategy to keep them alive. Extreme temperatures can kill them in the soil. Luckily in the UK we don't have to do too much of that, so that's not normally a big issue. Desiccation is a big one. So desiccation is one of the key killers for the nematodes. So keeping the soil moist is really important. And as well as that, is keeping enough free water in the soil so they can move. To find a host, they need free water. So keeping enough free water in the soil is important as well for them to find a host and survive. And then soil texture. Generally sandy soils are better for survival than clays or loams where they struggle to get through the soil and move effectively. And also there's predators in the soil as well. So there's a number of factors that can be really important in keeping them alive. But typically they last up to about 2 weeks in the soil. And other important factors to keep them alive as much as possible. Using in conjunction with nematode, that will help keep the soil moist and get the nematodes through the thatch layer into the soil where the grubs are residing. Irrigating them immediately, so that prevent them being killed by UV light or desiccating on the leaf. Get them off the leaf into the soil as much as possible by irrigation, and then keep the soil moist for 2 weeks if you can after the application, and that will keep the survival as high as you possibly can. So that was it from me. What we're going to do now is hand over to Sarah, and she's going to take you up close and personal to the nematodes and their hosts.
Today we're going to take a look at some of these infective juvenile entomopathogenic nematodes and have a look at what they look like under the microscope and after they've infected an insect to see just that reproduction and what actually happens to the insect. And then we'll also have a look at the formulation, how they are inside of the pack, just so you understand how we deliver these nematodes. So first, let's have a look at the infective juveniles. This is some of the NemaTrident that we have mixed with some water, just as you would do when you're doing an application. As you can see on the screen, there are lots of entomopathogenic infective juvenile nematodes here. You can see them moving around in the water. They have some characteristics of the infective juvenile entomopathogenic nematodes. So these dark bodies that you see are lipid reserves inside of the entomopathogenic nematode. These lipid reserves are their energy, and this is what helps them have the energy to go out and find a host to infect and complete its reproductive life cycle. They have a tough outer cuticle that helps protect them from the environment that you don't see on the other life stages. You can see that they're moving here, and this is because all of these NemaTrident products are alive. When they're delivered to you, they're ready, they're prepared, and they are living organisms, and this is why they can go and do what they do. Now we're going to have a look at some insects that were infected. So I've used some mealworms here as an example. Obviously, as Rod described, you might be targeting leather jackets in the field, but this is a good example for use inside of the lab. So these are some mealworms that were infected with entomopathogenic nematodes. These were the ones that received just water treatment, no nematodes. They are alive, they're just hiding underneath the surface of this paper. These were infected with Heteraptitis, and these were infected with Steinernema about 8 days ago now. As you can see, they have turned black and are quite necrotic. Later, we're going to cut one open and release the nematodes that are now inside that cadaver. Here we have some mealworms that were infected just yesterday with entomopathogenic nematodes. The control is alive. Again, not very happy, but it is alive and moving. It's playing dead right now. But the entomopathogenic nematode infected mealworms are now very much dead, most on their backs. And this is the first stage of that infection, as Rod described, where the infective juvenile is entered through perhaps the spiracles, the mouth, the anus, delivered that bacterial load and caused septicemia inside of the insect. So now what we're going to do is cut one of these dead cadavers open and take a look at what was inside. After the infection with the initial infective juveniles takes place and they've released the bacteria from inside of their guts causing septicemia, the nematodes go through several reproductive life cycles until they've depleted all of the resources inside of this insect that they're infecting, and then they release the infective juveniles out into the environment. So this is one of the mealworms that was infected just a little over a week ago. So what you can now see on the screen behind me is some of the infective juvenile nematodes that have released from this cadaver. And those infective juveniles and other stages of nematodes here have filled the body, and this is now just a delivery vehicle of nematodes. There we go. So you can see the side of the body of the mealworm just there, a little out of focus. You can see just to the edge the entomopathogenic nematodes that are now exiting the mealworm where I made the cut with the scalpel. So the final thing that I will show you today is some of the entomopathogenic nematode formulation that you'll receive as the final product of NemaTrident. As you can probably see on the screen behind me, the formulation is consisting predominantly of the infective juvenile entomopathogenic nematodes. That's what the tangle of little worm-like structures you see there is. And then there are some co-formulants added. And the co-formulants are just there to help deliver the entomopathogenic nematodes to you, the grower, in the field, in an alive state, and help us to keep them safely stored inside of the product until they're delivered ready to use. The co-formulants help keep a little bit of moisture there so that the nematodes don't dry out, because they don't, as Rod said, particularly like being dried out. So thank you. I've now taken you through what an infective juvenile entomopathogenic nematode looks like under the microscope, what an infected insect cadaver looks like after infection with entomopathogenic nematodes, And we've finally taken a look at the formulation of NemaTrident, what that looks like and how you'll receive it as a product. So thank you, and have a good day.